To do one round of the SHA-256, we start with 8 inputs, A, B, C, D, E, F, G, H. For the first round, these are constants provided by the NSA, no joke. So our first step is going to be convert these to binary, which is straightforward but a little tedious. So we'll start with ABC. 6 is 0110, 1010, 0000, 1001, E1110, 6011, 601. Now for the first operation, we're going to compute the majority function on A, B, and C. What that means is simply we look at each of the 3 bits and see are there more zeros or ones. 010, there's more zeros. 100, more zeros. 111, ones win. 011, ones win. 0, 1. And what this does is it mixes up A, B, and C in a nonlinear way, which makes it harder to break the hash function. Now we'll convert this back to decimal. 0011 is 3, 7, 8. Okay. Now our next step is we're going to take A and we're going to shift all the bits 2 positions to the right. So we're going to start here. 0110, 1010, 0000, 10. We shift A right 13 bits. We shift the whole thing 22 positions to the right. Now our next step is to sum these 3 shifted values. We're doing it modulo 2, or we're XORing the 3 bits together, or as it's easiest to think of, we are simply looking to see if it's odd or even. If there's an odd number of 1s, we put a 1. If there's an even number of 1s, we put a 0. If there's a 1, that's odd, odd, even, even. So CE20B47E is the result of our summation here. Now we're going to move down and look at EFG. We're going to convert these to binary. 5, 0, 0. Now we're going to combine E, F, and G in an interesting nonlinear way, which is called the choosing. So what we do is, if for each bit of E, if it's 0, we circle the bit of G. If it's 1, we circle the bit of F. 0, we circle G. 1, we circle F. And now we write down the circled bits underneath here for our choice. 0001, 1111, 0. Next, we're going to shift E by 6, similar to how we did with A. So we're going to start 4, 5, 6 right here. 5, 1, 0. Then our final shift is by 25 bits. We're going to sum the 3 bits together, modulo 2, odd or even. So check this, 3587272B. So that's our summation. Now, the next step is to combine all this data to make our first sum. So we go over here, we're going to start with W, which is our input. So this is actually the first place that our input data is actually going into the hash. 02000000. This actually indicates our data block is version 2. Now we take another constant provided by the NSA, 428A, 2F98, and we take our value H, which is just the same value we started with, unchanged, 5BE0, CD19. We take our choice value we computed earlier up here, which was 1F85C98C. And we take our summation of E, which was 3587272B. And now we add these these values up in hexadecimal. It's just plain arithmetic except base 16, which makes it a little tricky. 8 and 9 is 17, and 12 is 29, and 11 is 40. So that's 32 plus 8, so 16 plus, carry the 2, 16 plus 16, and 8. 2 and 9 is 11, 12 and 8 is 20, 22. That's 16 plus 6, so we carry the 16. 1 and 15 is 16. Plus 5 is 11, 12 and 3 is 15. So our result is F577ED68 is our first sum. Next, we go up to compute our new A value. We add three things here. We start with the sum we computed earlier, which was CE20B47E. And we take the majority value we calculated from A, B, and C. That's 3A6F, E667. And finally, we take our previous sum, which is F577ED68, and we just add these up in hexadecimal. So now this is our new A value. So after all this work, we've calculated one of our new values for the output. Now the new B is simply the old A value. Easy. New C is simply the B value. New D is our old C value. And now to compute our new E value, we're going to take D, which is A5, 4, F5, 3A, and we're going to add our previous sum, which was F5, 7. That's our new E value, and our new F value is our old E. Our new G comes from here, and our old G becomes our new H. So we have now completed one round of the SHA-256 hashing.